Hello everyone, welcome to Brain Blitz Audios. Today we'll be looking at NCERT textbook solutions for mathematics. Today we'll be looking at grade 7 and we'll be looking at the 7th chapter of the Max NCERT textbook, which is Congruence of Triangles, exercise 7.2. So let's begin, shall we? First question. Which congruence criterion do you use in the following? 1. Given AC is equal to DF, AB is equal to DE, BC is equal to EF, so triangle ABC is congruent to triangle DEF. So we have to find out which congruency criterion we should use. So the congruency criteria are SSS, SAS, ASA and RHS. So we have to find out which is being used so that we can get the final statement, this final statement. Now to find this, we have to look at what is given to us. Now it's given that AC is equal to DF. That's AC and that's DF. Now AC and DF are sides, so we write side over here. Next we have AB is equal to DE. AB and DE are sides of the triangle, so we write side again. Then we have BC is equal to EF. BC and EF are sides of the triangles, so we write side. Now to find out which congruency criteria, we have to observe these three. Now these three are sides, side, 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 so it will be SSS congruency criteria, side, side, side congruency criteria, which looks at all the sides of a triangle and compares with another side, another triangle. So the answer for this question is SSS congruency criteria. Next question. Given ZX is equal to RP, RQ is equal to ZY, angle PRQ is equal to angle XZY, so triangle PQR is congruent to triangle XYZ. Now let's follow the same procedure we did in the previous question. The first one, we have ZX is equal to RP. Now ZX and RP are sides, so we write side over here. Now RQ is equal to ZY. RQ and ZY are sides, so we write side over here. Now the third one is that angle PRQ is equal to angle XZY. So these are the two angles. So since they are both angles, we write angle over here. Now we compare. Now it's not necessary that the statements will be given in the order of the in which the congruency criteria is written. So we have to check if we have to check it. Now we can see side, side and angle. We can form the SAS congruency criteria, but we have to check if the angle is between the two sides. As we can see, PRQ is between PR, RP and RQ. So and XZY is between ZX and ZY. So that means that the angle is between the two sides, so SAS. So the answer is SAS congruency criteria. Next question. Given angle MLN is equal to angle FDH, angle NML is equal to angle GFH, ML is equal to FG. So triangle LMN is congruent to triangle GFH. Now let's see each of the statements given. Angle MLN is equal to angle FGH. This angle MLN is equal to angle FGH. These are both angles, so they are angles. Next we have angle NML is equal to angle GFH. Angle NML is equal to angle GFH. So these are angles. Then we have ML is equal to FG. ML and FG, both are sides. Now we have to if we are given angles, we have to check two angles and one. If we are given two angles and one side, we have to check if the side is between the two angles. Similarly, in the previous question, if we are given one angle and two sides, we have to check if the angle is between the two sides. Now in this, we can clearly see that the side is between the two angles. So, and since we have two angles and the side in between, it will be ASA congruency criteria. So the answer for this question is ASA congruency criteria. Next question. Given EB is equal to DB, AE is equal to BC, angle A is equal to angle C is equal to 90 degrees. So triangle ABE is congruent to triangle CDB. Now let's check at each of the statements. EB is equal to DB. Now this EB is equal to DB. Now so both of them are sides, so we write them as side. Then we have AE is equal to BC. AE is equal to BC. Both are sides. And then we have angle A is equal to angle C. Angle A is equal to angle C. It's an angle. Now we have to check if the angle is between the sides. But in the figure, as we have marked the angles in sides, we can clearly see that the angle is not between the two lines. Now let's focus on the third statement. Angle A is equal to angle C is equal to 90 degrees. Now since one of the angles of this triangle, of both of these triangles, is 90 degrees, that's why both of the triangles would be right angle triangles. And the congruency criteria, which is most often used, is the RHS, right angle hypotenuse side. Now we can check if it qualifies. Now EB and DB. Now EB is opposite of the right angle and DB is opposite of the right angle. So this is a hypotenuse. Now AE is equal to BC. AE and BC, they form they are sides of the triangle, two different sides, perpendicular base, one of them. So they are they form the side. And then we have the angle. Now since the angle is a right angle, as it's clearly specified, we'll write a right angle. Now these three form RHS congruency criteria. So the answer for this question is RHS congruency criteria. Next question. You want to show that triangle ART is congruent to triangle PEN. If you have to use SSS criterion, then you need to show 1. AR is equal to 2. RT is equal to 3. AT is equal to. Now to do this question, as we have explained in the previous episode, we have to write both of the names of the triangle on top of each other, and in the correct order as it's given in the congruency statement. And then we can see that A is equal to P. Angle A is equal to angle P, angle R is equal to angle E, and angle T is equal to angle N. Now AR. And now the first one is AR. Now to find this, you have to split it into two parts, A and R. A is corresponding to P and R is corresponding to E. So AR is equal to PE. Next question is RT. Now R is equal to E and T is equal to N. So RT is equal to EN. And then third question, AT. A is equal to P and T is equal to N. So AT is equal to PN. So these are the answer. This is the answer of the question. AR is equal to PE, RT is equal to EN, and AT is equal to PN. Next question. If it is given that angle T is equal to angle N and you are to use SAS criterion, you need to have 1. RT is equal to 2. PN is equal to. Now it's this same part of the question of the previous question. It's given that they have given us a statement. Angle T is equal to angle N. Let's write that down. So angle T is equal to angle N. Now the criterion they asked us to use is SAS. And the full form of SAS is side, angle, side. So that means then we look at the statement given. It's angle T is equal to angle N. So clearly they have given the angle. So what we have to find is the two sides. And those are the two questions given. First one is RT. Now first let's mark the angles given. Angle T and angle N. And then we have RT. Now RT, we write the two triangles on top of each other. So that means that now R is equal to E and T is equal to N. So RT will be equal to EN. And then next question we have Pn. P is equal to A and N is equal to T. So Pn is equal to AT. Now we can also find that out by when we write the angle. Since it's SAS, it will be between the two sides, and the two sides of the first triangles are T and AT, and the two sides of the second triangle is EN and PN. So this is the answer for this question. RT is equal to EN and PN is equal to AT. Next question, if it is given that AT is equal to PN and you are to use Asa Criterion, you need to have 1. So for this we have to give two statements to justify that we have to use the Asa criteria to prove that both these triangles are congruent. Now the statement given is AT is equal to PN, and the criteria we have to use is ASA. ASA is angle, side, angle. Now the statement given is AT is equal to PN, and since they are sides, we can cut sides from ASA. So we have to find two angles. Which two angles, you may ask? Now let's mark AT and PN on the figures. This is AT and this is PN. Now ASA criteria means that the side is between the two angles. So the side we have just drew. So the side AT must be between two angles and side PN must be between two angles. Now to find which two angles, we have to look at the statement. The statement is AT. Now in AT we can divide it to two parts, A and T. Now these both are angles, so the edge of each side will form an angle. So the angles of side AT would be angle A and angle T. Now if we have to find the same in the second figure, we'll write the two triangles on top of each other. And so angle A is equal to P, so angle A will be equal to angle P, and angle T is equal to angle N. So the two statements, the answer of this question is angle A is equal to angle P and angle T is equal to angle N. Next question. You have to show that triangle AMP is congruent to triangle AMQ. In the following proof, supply the missing reasons. Now we have some steps given, some statements given, and we have to find the reasons why it is true. Now we don't have to give an elaborate reason for this, we just have to give a one-word answer. Now let's look at the first one. First one is PM is equal to QM. Now let's mark them on the figure. Now you can notice that the two lines on PM. Now these two lines means that since PM has these two lines, if any other side has these two lines, then that means that angle PM, the measurement of angle PM would be equal to the measurement of that angle. Now in QM also we can see two lines, so that means the measurement of angle measurement of PM is equal to the measurement of QM. So The reason for which PM is equal to QM is given because it's given with two lines. Second question, angle PMA is equal to angle QMA. Now in angle PMA, there are two lines. They are represented using two lines. So in the same case as in the sides, in angles also, if they are represented by two lines, and if any other angle has two lines, then that means those two angles are equal. Now angle AMQ also has the two lines, so that means that angle PMA is equal to angle QMA. The reason would be given. Third one is AM is equal to AM. Now AM in this figure is part of both triangles, both triangle AMP and AMQ. So that means that the measurement of AM would be same in both the angles, and the reason would be that they are common in both the triangles. So AM is equal to AM, reason common. And the fourth one, we have triangle AMP is congruent to triangle AMQ. Now let's look at the first, second, third statements. The first statement is PM is equal to QM, so it's a side. Second one is an angle. Third one is also a side, and the angle is between the sides. So that means that using the three steps, we can find the first step. Triangle AMP is congruent to triangle AMQ using the SAS Congruency Criteria. So this is the answer for this question. Next question. In triangle ABC, angle A is equal to 30 degrees, angle B is equal to 40 degrees, and angle C is equal to 110 degrees. In triangle PQR, angle P is equal to 30 degrees, angle Q is equal to 40 degrees, and angle R is equal to 110 degrees. A student says that triangle ABC is congruent to triangle PQR by AAA Congruence Criterion. Is he justified? Why or why not? Now for this question, let's look at what the student has given. Now the student says that the two triangles are congruent by the AAA Congruency Criterion. Now this is wrong because there is no such congruency criteria as AAA. There's only SSS, SAS, ASA, and RHS. And for a better way to explain that AAA congruency criterion will not work, let's take two triangles, triangle ABC and PQR. Now is 110 degrees, 30 degrees, and 40 degrees. Now let's say this is triangle ABC. Now and this is triangle PQR. So then you can see that ABC and PQR has the same number of angles, 30 degrees, 40 degrees, 110 degrees. but their size is different. And the meaning of congruence is that each side, each vertex must overlap each other, and they must fit in the same shape. But even though they have the same angles, they are not fitting in the same shape. So that means that the justification given by the student, triangle ABC is congruent to triangle PQR by AAA congruence criterion is wrong. And the reason is that there's no such congruence criterion such as AAA. Let's move on to the last question. In the figure, the two triangles are congruent. The corresponding parts are marked. We can write triangle RAT is congruent to. So for this question, we can use two methods, that is the Sas Congruency Criteria or the Asa Congruency Criteria. Now, I'll be using the Sas Congruency Criteria. Now, if we look at AT, we can see there's one line marked on it, and in line NO we can also see there's one line marked on it. So that means that AT is equal to NO, and the reason is it's given. Now, and also AR has two lines, and so does OW. So that means that AR is equal to OW. Now, for the first one is incorrect because it must be ON, since A is equal to O and T is equal to N. AT is equal to ON and AT is not equal to NO. Then we have AR is equal to OW. Now, the angle between it we can see is angle A and angle O. Now, since they are marked with two lines, that means that angle A must be equal to angle O. Reason given. Now, that means that ON and AT are equal to each other. OW and AR are equal to each other, and angle A is equal to angle O. And since we have two sides and one angle, and the angle is between the two sides, we can say that triangle RAT is congruent to triangle WON by Sas Congruency Criteria. Now, the reason why I wrote RAT is equal to WON is because in the sides we mark, we can see that if we write AT and ON over each other, we can see that A is equal to O and T is equal to N. And also in the second statement we wrote AR is equal to OW, A is to O, and R R is to W. So that's how I got that triangle RAT is congruent to triangle WON by the Sas Congruency Criteria. That's all, folks. We hope you found it interesting. We'll be continuing this exercise in the next video. For more such videos, please subscribe to our channel, Brain Blitz Audios. Until the next episode, take care, stay safe, ta-ta for now.